Good morning, Mr. McElway. There are as many different aircraft engine maintenance plans as there are airline operators. We chose one specific plan for two reasons. It is unique and it is successful. The operator is American Airlines. Most of their preventive maintenance and line maintenance activity is performed at your LAX facility. These borescope photos show the kind of parts deterioration that must be monitored. High-pressure turbine blade tip deterioration, combustor distress in the dome area. Another example of combustor distress. First stage high-pressure nozzle deterioration. A general shot of the condition of the first stage turbine blade. The combustor outer liner. The inner liner. Your mission, Mac, if you care to aid me in this venture, is to assist us in documenting the events of a typical day's activity within the American Airlines CF6 engine maintenance management system.
Our story begins at American Airlines Maintenance and Engineering Center in Tulsa, Oklahoma, with this man, Johnny Johnson. He is American Airlines Engineering Liaison in the Midwest for the CF6 fleet. As a result of his daily routine, he's picked up a trend on an engine. His first act is to call for all CF6 DC-10 maintenance action for the past 10 days. He does this by typing into the computer a code number and the tail numbers of the aircraft and that engine position. The American Airlines computer program then gives him a printout of all the pertinent information. One of the monitoring techniques he has at his disposal, which is unique to American Airlines, is the lube system surveillance by spectrometric oil analysis, or SOAP for short. This program consists of extracting oil samples from the engine at regular intervals and processing them through the spectrograph. The extracted oil samples are automatically analyzed during the burning process. The identified elements in the oil sample are then fed into the computer. Johnson is now studying the spectral readout, the oil analysis for the engine. There are two things he'll be looking for on this page: the engine's oil consumption and the type and quantity of particulate contamination separated into atomic elements contained in the oil. It shows an upward trend to the present level of 14 parts per million iron. Here is typical debris found during a screen check on another engine. The online examination of the screen was triggered by a spectro trend and has been verified by visual inspection of the engine screens. Another important function at Tulsa is verification of hardware defects. Inspection by Borescope at the line station, in this case Los Angeles, detected and recorded combustor deterioration. This action was initiated by an observed trend on the Camille. Johnson is now looking at the Camille, the condition engine monitoring log, an engine parameter trending log. It plots engine trends for the past 30 days. Johnson has spotted a trend on the chart, alerting him to possible deterioration of the engine's hot section. His decision is to request a look at the engine. There are two things to do. First, find out where the airplane is that day, and secondly, see where he can have it routed for a maintenance check. He learns the airplane will be at LAX, where it will remain overnight. But what Johnson wants done is not part of scheduled maintenance. He asks Los Angeles if they can handle his request. And they confirm that they can, and it is noted on the station sheet. Johnny Johnson has made his decision. Based on his inputs, the Camille, oil analysis, and computer printouts, he's decided that the engine should be examined more closely. Now the ball is in Dick McElway's court. He and his crew will be looking at the actual hardware that night. American Airlines Los Angeles is also the fleet base for 747s as well as DC-10s. McElway's team will have other airplanes to inspect, some of them routine. Some will be unscheduled, like the DC-10 in our film. To prepare the airplane for its nightly inspection, American Airlines usually tows it from the terminal gate to the hangar. The twilight shift, the crew that works from 4 p.m. to midnight, gets the aircraft ready for inspection. The night crew, in this case McElway's, usually does the actual inspection, but not always. When an airplane comes in for its periodic maintenance visit, any crew might draw the inspection assignment. We are looking at the combustor liner report. This report lists the aircraft and engine position, the engine serial numbers, the last date of inspection, and the condition code at that inspection. As the engine deteriorates, the code will reflect the change in its condition. Having reviewed the combustion liner report, Mac pulls the engine inspection folder with the attached Borescope engine condition photos. Here is the real hard record of the engine's health. The experienced inspection supervisor can look at these pictures, which are a chronological history of the engine condition, and determine if the engine should remain in service or be pulled for maintenance. The Borescope pictures are the most definitive evidence of the combustor's condition. The trained observer can look at them and see if a crack has grown and by how much. It is really what the whole engine inspection plan is about. Mac has everything he needs now for the work to be done. He has his worksheets, work cards, and Borescope photos. He is ready to make his work assignments. As he passes out the work cards, Mac briefs his men on the night's work. He tells them that a DC-10 is on a watch check. He advises them that it is very important that they take a thorough look at the combustor. He also alludes to the request for oil samples that Tulsa wants. A word or two about the crew. Each man is, of course, a skilled technician, thoroughly trained in his job. But he is more than that. He is a man who has demonstrated an unusual interest in this work and really enjoys it. A man who has a specific aptitude for engine condition assessment and documentation. To maintain a high level of proficiency, it is required that they receive maximum exposure to the hardware in question. At American Airlines Fleet Base at LAX, there are 3 complete sets of Borescope equipment on hand. Each set is checked out regularly to assure it is physically and functionally sound. The Borescope set consists of a fiber light bundle and light projector, an M2 rotor turner, 3 borescopes, and a camera. One of the inspectors has requested that Mac take a look to evaluate the condition of the engine. He begins by borescoping the first stage of the high-pressure turbine. As the turbine is turned, we can see there is a bit of brazing visible on the blade platform. There is also a bit of coloration along the leading edges and some carbon streaking. But the turbine is all right. The inspector now moves past the firewall to the 3 o'clock port in the combustor. Now we are looking into the combustor at the fuel nozzle dome area. There are 5 inspection ports available in this section of the engine. Here's a good view through the borescope of the combustor inner liner. The next visual inspection is through the 6 o'clock borescope port. If the inspector notices any deterioration, it's up to him to determine the magnitude. Normally, a 360-degree sweep of the borescope will consume approximately 15 seconds. This is probably the most important aspect of the Borescope inspection, the Polaroid record. It goes into the engine file folder where the component deterioration can be compared with previous photos. It also permits more than one person to look into the engine at the same time, and everybody is seeing the same thing. Another very useful tool is GE's low-light level TV camera, which has been used very effectively in evaluating internal engine condition. Here we see an axial crack in the combustor inner liner. The engine proved to be serviceable. It will be recalled that Johnny Johnson had requested an oil sample of the engine. This is how it is taken. The mechanic removes the oil-filled cap, checks the dipstick, and then inserts an accordion-type throwaway suction bottle into the oil tank and fills it. The tube is then removed from the engine, and the bottle is capped. The sample is ready for Tulsa. The engines have been found serviceable, and the DC-10 has been released for flight. The aircraft will be scheduled back for additional engine watch checks until such time as programmed removal is necessary. The night's work has added further documentation to the engine condition file. The photos taken during this evening's inspection now become part of the data bank and furnish hard copy for the Fleet Experience file. Data such as these provide experience-proven deterioration notes, from which can be established valid inspection intervals, early awareness of fleet problems, comprehensive analysis of engine hot section condition, and furnishes justification for procurement of replacement parts.